Welcome to Astronomy Daily. I'm your host, Anna, and I'm thrilled to have you join us for another exciting dive into the cosmos. Today, we're covering some big headlines from across our solar system and beyond. First up, we'll hear about an astronaut mission returning from the International Space Station, wrapping up a busy period of scientific research. Then, we'll turn our attention to the groundbreaking efforts to cultivate fresh food in space, a crucial step for future long-duration missions to the Moon and Mars. Next, we'll celebrate the James Webb Space Telescope's third year of operations with an absolutely stunning new image that reveals the secrets of a cosmic cat's paw. And finally, we'll shift our gaze to our own star, the Sun, as an active sunspot that's been putting on an explosive show with magnetic bombs turns its fiery gaze towards Earth. So buckle up and let's explore the latest in astronomy. First up today, we have news from the International Space Station, where the Axiom Mission 4, or AX-4 crew, is making final preparations to return to Earth after a highly productive 2.5-week research mission. Mission managers have given the green light for Commander Peggy Whitson, pilot Shubhanshu Shukla, and mission specialists Sławosz Uznański-Wisniewski and Tibor Kapu to board their SpaceX Dragon spacecraft. They are set to undock from the space-facing port on the Harmony module this coming Monday, July 14th, at 7:05 a.m. Eastern Daylight Time. This private quartet has had an incredibly busy schedule, packed with a diverse array of scientific investigations aimed at advancing our understanding of human health in space, sustainable life support systems, and next-generation technologies. Just a few days ago, the AX-4 crew was focused on collecting blood samples for a comprehensive biomedical research study, crucial for understanding how the human body adapts to microgravity. They also delved into the potential of microalgae, exploring its viability as a food source for future crews and its role as a key component in biological life support systems aboard spacecraft. Imagine the possibility of astronauts cultivating their own fresh food during long-duration missions. In another fascinating area, the crew investigated nanomaterials, which could form the basis for constructing advanced wearable devices designed to comfortably monitor crew health, providing real-time data on their vital signs and overall well-being. As the mission drew to a close, the AX-4 team spent their final days finalizing several other important science experiments. This included an electrical muscle stimulation study, which could offer insights into maintaining muscle strength in low gravity. They also tested suit fabrics engineered to promote thermal comfort during exercise, a critical factor for astronaut performance. And, in an effort to understand the psychological aspects of space travel, they filmed crew activities for a behavioral health study. On Sunday, their focus shifted to the meticulous task of packing all the science gear, including precious research samples, along with their personal items and other cargo, securely inside the Dragon spacecraft for retrieval once they are back on Earth. It wasn't just the AX-4 crew who were busy, though. The International Space Station's resident crew members were also deeply involved in assisting and continuing their own research. NASA flight engineer Anne McLean, for instance, helped the AX-4 crew gather hardware and other items for packing. She also continued assisting the private crewmates as they utilized the station's resources for their ongoing science investigations. NASA flight engineer Nicole Ayers spent her day in the Columbus Laboratory module, where she assisted the AX-4 crew by spinning astronaut blood samples in a centrifuge and then carefully stowing them in a science freezer for preservation. She later moved to the Quest airlock to transfer water into a pair of spacesuits. NASA flight engineer Johnny Kim also lent a hand with the blood sample processing before spending the rest of his day inspecting electronics gear and swapping computer cables. Meanwhile, Station Commander Takuya Onishi from the Japan Aerospace Exploration Agency, or JAXA, started his day processing saliva samples for analysis and then recording his sleep experience for a computer questionnaire. He later worked in the Tranquility module, replacing orbital plumbing hardware before deactivating and stowing a microscope in the Kibo Laboratory module. From the Russian segment, Roscosmos flight engineers Sergei Ryzhikov and Alexei Zubritsky took turns pedaling on an exercise cycle while wearing electrodes. This physical fitness evaluation provides researchers with crucial data to understand the energy requirements crew members need for strenuous activities like spacewalks. And flight engineer Kirill Peskov replaced fire extinguishers in the Poisk, Rassvet, and Zvezda modules, then checked computer hardware that supports the European robotic arm. It truly takes a global effort to keep the station running and to push the boundaries of science. Speaking of food for future space missions, one of the biggest challenges facing permanent human bases on the Moon and Mars is the ability to grow fresh food hundreds of thousands of kilometers from Earth. But exciting news on this front. The seeds of a rice variety ideal for growing outside Earth might soon be sprouting, thanks to an innovative collaboration called the Moon Rice Project. This joint effort brings together the Italian Space Agency, the University of Milan, the University of Rome, and the University of Naples, all working to create the ideal food crop for future deep space outposts. Dr. Marta Del Bianco, a plant biologist from the Italian Space Agency, explains that they are essentially trying to solve the same problems we face here on Earth, but in a much more extreme environment. Given the negative effects space can have on human health, it's crucial for astronauts to have readily available, nutrient-rich food. Currently, space exploration relies heavily on pre-packaged meals delivered during resupply missions, which rarely include fresh ingredients. One of the major hurdles for farming in space is the sheer size of crops. Even small varieties like dwarf rice are still too big to depend on in the confined spaces of a spacecraft or lunar habitat. What we need is a super dwarf, says Del Bianco. However, creating a super dwarf rice comes with its own set of challenges. While scientists can manipulate a plant hormone called gibberellin to reduce the height of rice plants, this can negatively affect seed germination and production. As Del Bianco points out, they're not an ideal crop because in space you don't just have to be small, you must also be productive. The project is delving into various aspects of rice biology and genetics to develop this perfect crop, one that can nourish humans on long-duration missions. The project is only 9 months into its 4-year plan, but the preliminary results are already looking very promising. Dr. Del Bianco's specific focus is on microgravity and how these rice plants will cope in that unique environment. To simulate microgravity on Earth, they continually rotate the plant so it's pulled equally in all directions by gravity, effectively confusing the plant about which way is up or down. Additionally, researchers at the University of Milan have identified rice mutant varieties that grow to a mere 10 centimeters high, while the team in Rome has pinpointed genes that can maximize growth and production. Beyond just size and yield, Del Bianco and her team are also aiming to increase the protein content of the rice, as meat production for long-duration missions will simply not be effective. Apart from being highly nutritious, they hope this crop will also offer significant benefits for the astronauts' well-being. Watching and guiding plants grow is known to be good for humans, and while pre-cooked or mushy food might be fine for short trips, it could become a real concern on longer missions. Imagine the psychological boost of having fresh, growing food in a sterile space environment. As Del Bianco puts it, if we can make an environment that physically and mentally nourishes the astronauts, it will reduce stress and lower the chances of people making mistakes. This groundbreaking research isn't just for space either. The hope is that if they can develop such a robust crop for space, it could also be used in challenging terrestrial environments like the Arctic, Antarctic, deserts, or even in places with very limited indoor growing space. The preliminary findings of this fascinating project were recently presented at the Society for Experimental Biology annual conference in Antwerp, Belgium. From the challenges of growing food in space, let's now turn our gaze to something truly spectacular that celebrates the 3rd year of operations for the James Webb Space Telescope. Prepare to peer into the heart of a cosmic wonder, the Cats-paw-nebula, a giant complex molecular cloud aptly named for its striking resemblance to a set of enormous toe beans. This isn't just a squishy-looking cosmic temptation. The Cats-paw-nebula, located approximately 4,000 light-years away in the constellation Scorpius, is a vibrant site of ongoing star formation. Here, massive stars are in the active process of forming, often obscured by vast clouds of dust and molecular gas. This is where JWST truly shines. Infrared light, unlike other wavelengths, has the remarkable ability to penetrate these dense clouds, where other light would simply scatter off the particles. As the James Webb Space Telescope is an infrared telescope, it is perfectly equipped to peer directly through the dust and reveal the wild, intricate process of star formation unfolding within. It's an excellent tool for investigating these cosmic nurseries. The telescope's near-infrared camera, or NIRCam, captures different stages of this stellar birth process throughout the scene. In the upper middle chamber, a structure affectionately nicknamed the Opera House, we can spot a baby yellow star actively illuminating and blowing away the surrounding dust. This represents one of the final stages of a star's formation. Meanwhile, in the thick brownish dust right in the middle of the image, you can see glowing, fiery red blobs. These are sites where star formation is still actively underway, heavily obscured by the nebular material. An orange region in the upper right, with a noticeably low star count, indicates an area where star formation is in its even earlier stages. The beautiful opalescent blue glow illuminating the hollowed-out areas comes from the light of fully formed stars scattered throughout the cloud. And those intriguing filaments of dust, through which very little light penetrates, suggest areas of such high density that the star formation process is just beginning. Dense knots of gas collapsing under gravity to form the very seeds of baby stars. Against this backdrop, bright blue-white stars gleam with crackling clarity. These are the fully formed stars that have successfully blown away their surrounding material, now free to shine their light across the cosmos. It's a truly magnificent and dynamic portrait of stellar birth. If you'd like to see this breathtaking image for yourself, wallpaper-sized versions are available for download on the European Space Agency's JWST website. I'll drop a link into the show notes for you to check it out in all its glory. It's an incredible way to celebrate 3 years of groundbreaking discoveries from this phenomenal telescope. Now, let's shift our focus closer to home, to our very own star, the Sun, which is putting on quite a show. A new sunspot, designated Region 4136, has recently emerged over the Sun's eastern limb, and it's crackling with dozens of magnetic explosions known as Ellerman bombs. French astrophotographer Philippe Tosi captured this incredible activity on July 10th from Nîmes, France, using an H-alpha filter to reveal the fine details of these explosions. The image shows these Ellerman bombs popping like fireworks near a sunspot that has already unleashed multiple M-class solar flares, which are mid-level eruptions on the solar flare scale. Ellerman bombs were first described in the early 20th century by physicist Ferdinand Ellerman. These energetic events occur in the lower solar atmosphere and are primarily driven by magnetic reconnection. This is a process on the Sun where oppositely charged magnetic fields meet and then explosively reconfigure, releasing a burst of energy. Each Ellerman bomb might release an amount of energy equivalent to roughly 100,000 World War II-era atomic bombs. While that's only about 1/millionth the energy of a large solar flare, these mini-explosions are highly significant. They are seen as key indicators of magnetic complexity within a sunspot. When opposite magnetic polarities collide and reconnect, they quickly release energy in these bright, rapid flashes. That complexity could potentially mean even bigger fireworks ahead. With sunspot region 4136 now rotating to face Earth, it could pose a threat for stronger space weather events in the coming days. M-class flares, like those already observed, have the potential to cause brief radio blackouts and minor satellite disruptions if they are aimed directly at our planet. Scientists and skywatchers alike will certainly be keeping a very close eye on this active sunspot region as it continues its rotation into an Earth-facing position. It's a dynamic reminder of the powerful processes constantly at play on our star. That's all for this episode of Astronomy Daily. Thank you for joining us for another exciting journey through the cosmos. It's truly incredible what we continue to discover, from returning astronauts and future food sources for space, to the breathtaking beauty of nebulae and the powerful dynamics of our own sun. For more astronomy news, make sure to visit our website at astronomydaily.io. There, you can sign up for our free daily newsletter to get the latest updates delivered straight to your inbox, and you can also listen to all our back episodes. You can subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts so you never miss an episode. I'm Anna, your host, and we hope you'll join us again soon for more amazing stories from across the universe. Until then, keep looking up. There's a lot going on out there.